Hello everyone, welcome back to Deeksha Karnataka YouTube channel. Today I am going to discuss top 30 questions from the chapter Magnetism and Matter. This is relatively medium important chapter. Maximum 3 questions you can expect from this chapter. Also very important part is that when I was trying to compose the questions, I realized that a lot of questions, lot of part are deleted from this chapter. Hysteresis related questions, okay, and then the time period related questions, a lot of questions, Curie temperature related questions. So they are all deleted from the syllabus. So the overall coverage of the syllabus chapter is reduced. So you can expect maximum 2 questions from this chapter in upcoming 2025 exam. Okay, now let's start with today's session. Universal property among all substance is diamagnetism, paramagnetism, ferromagnetism, non-magnetism. So out of all 3 properties of magnetic material, diamagnetism is the universal property. Universal property means it exists in all type of materials. Okay, it exists inside a ferromagnet, it exists inside a paramagnet, obviously diamagnet it exists, but in case of ferromagnet, the ferromagnetic property dominates the diamagnetism by such a way that it is not visible. Similarly, for the same for paramagnetic substance as well. So universal property is diamagnetism, it exists in all types of material. Now a susceptibility of a certain magnetic material is 1400. What is the class of the magnetic material? So susceptibility is very high. So if the susceptibility is very high, then definitely it's a ferromagnetic material. So correct answer is ferromagnetic material. Now obviously if you want to prepare well for your upcoming KCET 2025 exam, along with your preparedness for the time that for which you are writing the exam, so you have to answer 60 questions for 60 minutes, so you need a lot of practice. So definitely here at Deeksha we are presenting you Abhyas test series which is available online and through our app. You have to click on the link given in the description, download the app, register yourself and then download the app. And obviously the course fee is 1498. Here you will get all the one-shot videos, all important 5 years insights of the KCET exam. Also you will get test paper, that is the main important part of this test series. Every day, almost every day, you are receiving one question paper from one of the subjects. You have to answer them, you have to answer and realize what mistakes you are making. So these are very important for your KCET 2025 preparation. If you have not yet part of this team, please decide yourself whether you want to be part of it or not. A lot of students have already taken part in it, and if you have not yet, then you are missing out on a big chance to prepare yourself. Now let's move on. Which of the following statement proves that Earth has a magnetic field? Let's see. Earth is surrounded by ionosphere. Okay, the intensity of cosmic ray streams of charged particles is more as the poles at the than that the equator. Large quantity of iron ore is found in the Earth. Earth is a planet rotating about the north-south axis. So main thing is Earth rotating in north-south axis. There are other planets also rotating in north-south axis, but they do not have any magnetic field. Only the proof of magnetic field is that the intensity of cosmic ray stream of charged particles is more at poles than at the equator. So basically at the poles the magnetic activity of Earth is higher. So and we know that moving charges do produce magnetic fields. That is why they get either attracted or repelled in the poles. That is why cosmic rays, basically cosmic rays are moving charges. They they generally get attracted towards the poles, and that is why we see aurora borealis, two types of aurora we see, north pole and south pole. Now Earth is surrounded by ionosphere. Ionosphere does not have any direct proof of Earth's magnetism. Only this is the direct proof that Earth is a huge magnet. So this is the correct answer for the question. Now let's go next question. In a permanent magnet at room temperature, domains are partially aligned. Domains are all perfectly aligned. Magnetic moment of each molecule is 0. the individual molecules have non-zero magnetic moment which all are perfectly aligned. So first this individual molecules does not have non-zero magnetic moment. They might have, but they are having aligned inside a particular zone, that is called domains, and at room temperature they are not all perfectly aligned. There are the individual molecules are still vibrating, and there are some domains which are aligned, some domains which are not aligned. If it is obviously, if it is the strongest magnet, if you align all of them, that is possible, but normally at room temperature domains are not perfectly aligned. They are aligned obviously, but they are not perfectly aligned. Okay, not all domains are perfectly aligned. Okay, if you take them to the absolute zero, then only all the domains will be perfectly aligned. Now, needles N1, N2 and N3 are made of a ferromagnetic, a paramagnetic and a diamagnetic substance respectively. A magnet when brought close to them. Now you might see that this question during our PU board preparation, a lot of questions here are from PU board preparation, but these questions are from your KCET exam, previous KCET year exams. So now some easier questions from this chapter are part of your KCET PU board preparation as well. But in the past, these questions came in KCET exams, okay, or in preparatory as a preparatory of KCET, you have to rely on these questions, because as I said, a lot of good concepts from this chapter are deleted, hard concepts are deleted. So the questions that you expect from this chapter are relatively easy. You should be able to answer them without doing a lot of mathematics. So this is an easy chapter. Okay, so attract all three of them. So first of all, needles N1, N2 and N3 are made of ferromagnets. So N1 is ferromagnet, N2 is paramagnet. So this is ferro, this is para and this is dia. We know that a magnet attracts ferromagnet strongly, it attracts paramagnet weakly and it repels diamagnet weakly. So attract N1 strongly, N2 weakly and repel N3 weakly. So obviously option is correct option is B. Okay, now so this is the correct answer. Obviously other options are, other combinations are incorrect. Now, next question, the magnetic intensity to completely demagnetize a ferromagnet is 3 into 10 to the power of 3 ampere per meter. The minimum current required to be passed in the solenoid having 1000 turns per meter, so that the magnet gets completely demagnetized when placed inside a solenoid. So what is the magnetic field inside a solenoid? Magnetic field inside a solenoid is mu Ni. Now there may be some other material present in it. Now we know that magnetic intensity H is equals to B by mu. So it is basically N into I. Now magnetic intensity, basically magnetic intensity is the under the influence of external field, how well they are producing an internal field, that is called magnetic intensity. So magnetic intensity to destroy the magnetization is basically 3 into 10 to the power of 3. So 3 into 10 to the power of 3. So this is the destructive magnetic intensity. And if we apply the same magnetic intensity in the opposite direction, then it will cancel. So we have to adjust the value of I such that this can cancel the value of H. So what is H? Magnetic intensity is 3 into 10 to the power of 3 and N is 1000. So I will be equals to, so 10 to the power 3, 1000 1000, right? Yes, 1000 cancels. So I equals to 3 ampere. So you have to pass a current of 3 ampere. Okay, so 3 ampere is the correct answer for this question. Now next question, consider the following statements. Statement 1, magnetic field lines do not intersect each other. Yes, magnetic field lines do not intersect each other. If the magnetic field lines intersect, the magnetic field would not be unique at the point of intersection. With reference to the above statements, both statements are true, and obviously statement 2 is the correct explanation of statement 1. So if we see two magnetic field lines, if they intersect, then at the point of intersection we will have two different direction of magnetic field, which is not possible. Magnetic field is a vector quantity, that means it will have a unique direction at each and every point, which is not possible if they intersect. Now next question, When the angle between the magnetic moment of a small compass needle and the uniform magnetic field in which it is placed is theta equals to 180 degree. Okay, so the angle between magnetic moment and the uniform magnetic field is 180 degree. Okay, the torque on the needle is maximum. What is the torque? Torque is mb sin theta. Okay, so what is the value of sine 180 degree? Sine 180 degree is equals to sine 0, which is equals to 0. So it will be 0. So torque is minimum. The needle is in stable equilibrium. The potential energy of the needle is 0. What is potential energy? So potential energy is mb minus mb cos theta. Okay, minus mb cos theta. So potential energy will be, now cos 180 degree is plus 1, so it will be mb. Okay, the needle is in unstable equilibrium. So as you can see that potential of the object is, even though the torque acting on the system is 0, potential is positive and it's very high. So this system is in unstable equilibrium. If it was in negative value, then we would have said that the system is in stable equilibrium. Torque 0 means it is in equilibrium. So no torque acting on the system, that means the needle is in equilibrium. Now whether it is stable or unstable, that depends on the potential energy. If potential energy is negative, smallest value, then we say this is in stable equilibrium, but here potential energy is positive, so and in fact potential energy is highest value, then it is in unstable equilibrium. Unstable means if you displace it by a small amount, it will flip and it will go to the parallel condition. If the theta is 0, then it is a stable condition. If it is 180 degree, it is unstable condition, but still it is in equilibrium. Now, a magnetized needle placed in a uniform magnetic field in general experiences both force and torque, a force but no torque, torque but no force, neither a force nor a torque. So magnetized needle placed in uniform magnetic field, so it is uniform magnetic field means only torque but no force. If it is non-uniform, then you will experience both torque and force, but because the field is uniform, only torque you will experience but no force. When freely suspended, a magnet comes to rest in the direction north-south. Easy question, right? Next question. The susceptibility of a ferromagnetic substance is greater than 1, 0, very very greater than 1, less than 1. So susceptibility of ferromagnetic substance is much greater than 1. So correct answer is very very greater than 1. If it is a diamagnet, then it will be less than 1. If it is paramagnet, it will be slightly less than 1, but small value. The dimensional formula for magnetic intensity. So what is magnetic intensity? We have just saw that magnetic intensity is B by mu, or it is N into I. Okay, from the solenoid problem, right? Solenoid, for solenoid B is equal to mu naught Ni. Now what is N? N is number of turns per unit length. So basically this dimension of N is L to the power minus 1. What is the dimension of current I? Dimension of current I is A. So dimension of magnetic intensity is L to the power minus 1 into current A. So this is the correct answer. Okay, this way you can remember two formulas at once. Okay, try to remember less amount of formulas, and whatever formula you remember, from there you can try to formulate whatever other questions you can solve, right? Next question. Which of the following properties is false for a bar magnet? It does not produce magnetic field. Its poles cannot be separated. It points in the north-south direction when suspended. Its like poles repel and unlike poles attract. So first of all, we have to find false statement, and that is for a bar magnet. So these two are very very important consideration. It does not produce magnetic field is basically first statement. You can see it is wrong statement. It produces magnetic field. Bar magnet does produce magnetic field. So first statement itself is wrong. Okay. Its poles cannot be separated, obviously correct. It points north-south direction when suspended. This is also correct. It like poles repel and unlike poles attract. That is also correct. The magnetic susceptibility of a material is 100. Its relative permeability is, so relative permeability is 1 plus susceptibility. Okay. So relative permeability is 1 plus susceptibility. So susceptibility is given 100. So relative permeability will be 101. Okay, it will be 101. In case they ask you the opposite, that what is mu r is 100, what is susceptibility, then it will be 99. Okay. For which one of the following substances the magnetic susceptibility is very high and positive? So they have given bismuth, copper, iron, sodium. So magnetic susceptibility is very high and positive for ferromagnetic substance. So out of all the given options, iron is having very high susceptibility and positive. So this is the correct answer. Next question. The atoms in which kind of magnetic materials have permanent magnetic dipole moment? Only, so which one of them has permanent dipole moment? So paramagnetic and ferromagnetic both has permanent dipole moment. In case of ferromagnetic substance, some permanent dipole moments, they align, they make a group, they align together and they form domain, but still the molecules still have permanent dipole moments in molecular level. So both para and ferromagnetic substances have permanent dipole moment. Which magnetic property shows strong attraction to an external magnetic field? Paramagnetism, diamagnetism, ferromagnetism, both paramagnetism and ferromagnetism. Only ferromagnetic magnetism shows strong attraction to external magnetic field, and paramagnetic shows weak attraction towards the external magnetic field. Diamagnetism shows weak repulsion of the external magnetic field. Next question. The ratio between magnetization and magnetic intensity is called permeability, is called relative permeability. It's a dimensionless quantity. It's reciprocal of susceptibility. So ratio of magnetization by magnetic intensity is basically susceptibility. Okay, magnetization is basically how susceptible it is into magnetic intensity. This is the relation. So from there we can say that this is a dimensionless quantity. It is not reciprocal of susceptibility, it is not relative permeability, it is the susceptibility itself, and susceptibility is a dimensionless quantity. So the correct answer is it's a dimensionless quantity. Very careful. Okay. Next question. A compass needle of magnetic moment M is placed in an uniform magnetic field B such that the angle between them is theta. The ratio of magnitude of the torque on the needle to the potential energy of the needle is proportional to. So what is the torque? Torque is magnitude MB sin theta, and potential energy minus MB cos theta. So ratio is tau by u is equals to minus tan theta. So this ratio is proportional to tan theta. Okay, based on which order they have given, very careful. Actually it is negative tan theta, but you can, negative tan theta is obviously proportional to tan theta, so you can say this is proportional to tan theta. Right. Next question. This is very interesting question taken directly from your NCERT textbook. The following figure shows a small magnetized needle P placed at point O. So here we have a small magnetic needle placed at O. Okay. The other arrow shows the different positions and orientations of the magnetic moment of another identical magnetic needle Q. Okay, so here we are placing another magnetic needle at different location, and we will see what is the condition. Which of the following statement is false for the above configuration? So there are 3 of them are correct and 1 is incorrect. You have to identify which one is incorrect. In configuration PQ1 and PQ2, the system is not in equilibrium. So PQ1 and PQ2, the system is not in equilibrium. So what is the angle in this case? So dipole moment, in this dipole moment, both cases the angle is 90 degrees. So obviously we know that torque is MB sin theta. So sine 90 means torque is mb sine theta. So here m is for q and magnetic field B is due to the original dipole. Okay, so because of this mb sine theta, theta is 90 degree, that means sine theta is 1, so torque acts on both cases. Okay, and the system is not in equilibrium, so definitely the system is not in equilibrium. This is the correct statement. The system will be stable equilibrium for configurations PQ3 and PQ6. System will be in stable equilibrium for PQ3 and PQ6. So what about PQ3? PQ3 situated along the perpendicular bisector. Very, very important part. So obviously PQ6 and P and Q6 are aligned, so they are in the same direction. So the angle is 0, theta is 0. Okay, so what is the electric potential? So we have solved one question previously, right? So electric potential energy is minus mb cos theta, right? So cos theta means here in this case cos theta is 0, so it will be minus mb. Okay, theta is 0 in both case. In this case, this is clear, right? PQ6 is clear, it is minus mb. Minus mb means least potential energy, so it is a stable equilibrium. Now in this particular case, okay, this particular case where we are discussing about P and Q3, very interesting and very important. In case of P is like this, and this is a perpendicular bisector. So if you remember the perpendicular bisector condition in case of electric dipole, okay, because magnetic dipole and electric dipole are same. So in this case of electric dipole, if the dipole moment was in this direction, the electric field along the axis was perpendicular bisector was in the opposite direction. There was a negative sign, if you remember, right? So basically the electric field due to this dipole is not in this direction because it is in the perpendicular bisector line. So the magnetic field will be in this direction. So magnetic field will be opposite to that of the dipole moment of the dipole. Okay, so this is why they are again aligned. So B and Q3 are again aligned. So in that case also the potential energy will be minus mb. So it is again in the stable equilibrium. So both PQ3 and PQ6 both are in stable equilibrium. This is little tricky. So to understand this question, sorry, this is not the correct statement. This is a correct statement, so this is not the correct answer. We are finding the wrong answer, right? Now next question, the system will be unstable equilibrium for configuration PQ4 and PQ5. Again, this is opposite. So this is opposite to the, this is the axial position. In case of axial position, magnetic field will be in this direction. So they are in the opposite orientation. So definitely it is unstable. Similarly, this is in the axial position. So in this case, the magnetic field will be opposite direction. So again, they are in the unstable equilibrium. Unstable equilibrium means the torque is 0, but potential energy is maximum. So that is unstable equilibrium. So Q6 correspond to the maximum potential energy state among the given configuration. Now Q6, we have already found that energy for Q6 is minus mb, which is the lowest possible configuration. Only 5 and 4 has the highest possible potential. In fact, Q5 has the highest because B is it is along the axis of Q4 is along the axis, so Q4 will have the highest potential energy, not Q6. Okay, so this is the wrong statement. This is the wrong statement. So correct answer will be P, option D. Very interesting, very elaborative, understanding question. So if you have understood that because the magnetic field will be opposite, because this is along the perpendicular bisector, then your half of your work is done. Okay. Now this is a slightly long question. Maybe the same concept will be applied. Similar question might come in your KCET exam. It is very, very probable one of such questions will come. Okay, because as I said, a lot of good concepts, difficult concepts are deleted from the chapter. So now they will try to answer, give you some concept related question from this chapter. When a bar magnet is suspended freely, it points in the direction of north-south. Next question, the ferromagnetic material among the following is. So ferromagnetic is not copper, only nickel, lead and calcium are not ferromagnetic. Statement 1, the net magnetic flux through any closed surface is 0. So net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by number of field lines entering it. So if it is a closed surface, number of field lines entering should be equals to number of field lines exiting, so that total flux inside the surface is 0. Net flux is 0. So both statements are true and 2 is the correct explanation. So option A is correct. The susceptibility of a diamagnetic substance is less than 1, so it will be less than 1. Okay. Which of the following properties is false for a bar magnet? It does not produce a magnetic field. I think this is a repeat question. This is the correct answer. It produces magnetic field. Next question. Susceptibility of a certain magnetic material is 4. What is the class of the magnetic material? So it is a positive value, but it is a small positive value. So this is definitely a paramagnet. Okay, 4 is definitely a paramagnetic substance. Next, the magnetic field lines inside a bar magnet are from north pole to south pole, are from south pole to north pole, do not exist only when the external field is present. So magnetic field inside a bar magnet is normally outside it is north to south and inside it is south to north. Okay, so it is inside it is south pole to north pole. Option B correct. When a bar magnet of dipole moment M is placed in an uniform magnetic field B, I think the question statement is missing. What is the potential energy of the dipole? Okay, the potential energy of the dipole, obviously cross product is not the potential energy, cross product is only gives you a torque, so potential energy will be m dot b. Okay, these two are same. Anyway, this is torque, this is potential energy. Okay, magnetization of a sample is magnetic moment per unit length, magnetic moment per unit area, magnetic moment per unit volume. This is the definition of magnetization. Magnetic moment per unit volume is the magnetization, capital M. Okay, magnetic moment per unit current, no. The net magnetic flux through any closed surface is 0. It is in accordance with Gauss's law in magnetism. In a permanent magnet at room temperature, domains are partially aligned, domains are all perfectly aligned, domains are partially aligned. This is, I think, again a repeat question. Now let's see this question. In the following table, column 1 lists magnetic substances and column 2 lists some magnetic properties of the substances. Okay, so diamagnetic substance, paramagnetic, ferromagnetic. So dia-para-ferro. Domains formation happens only in ferromagnetic, so we can directly see this is the correct matching for this. C is matching with Q. Okay, diamagnetic substances have chi-m greater than 1, so this is with diamagnet, and for my mistake, diamagnetic substance has, for paramagnetic substance, chi-m is greater than 1. Susceptibility is greater than 1. For diamagnetic, susceptibility is less than 1, and this is direct match. So A is matching with P, and so if you see, A is matching with P, and A with P, B with R, and C with Q. So correct matching is option B. So be careful, check the matching, and once you are confirmed, you check the answer. Next, the SI unit of magnetic flask is Weber per meter, Tesla per meter square, Weber per meter square. So magnetic flask is Weber, not Weber per meter square. Weber itself is the unit of magnetic flask. Also Weber is nothing but Tesla meter square. Okay, Tesla meter square is magnetic flask, also known as Weber. So I hope you enjoyed today's session. This was brief, short, but very important session. All the questions, as you can, as you have seen, that questions are easy from this chapter. We will be back with more such questions in future. Also, if you have not yet subscribed to our channel, don't forget to subscribe to our channel. Till then, bye.